Amazon is preparing to spend $220 billion in a single year, yet the company says it still cannot build enough computing capacity to satisfy demand. That is the contradiction at the center of the artificial intelligence boom. Amazon has more money, more data centers, and more cloud experience than almost any company on Earth. It is increasing its 2026 capital spending plan by another $20 billion. But customers have already reserved most of the new Amazon Web Services capacity expected to arrive in 2027, while some capacity planned for 2028 has also been committed. The AI industry is no longer waiting to discover whether companies want more computing power. The immediate problem is finding enough chips, memory, electricity, buildings, and network equipment to deliver it. Amazon's latest results show how quickly the market has changed. During the second quarter of 2026, Amazon Web Services generated approximately $42.2 billion in revenue, an increase of 37% from the same period a year earlier. It was AWS's fastest growth in 18 quarters. Oz also produced $16.6 billion in operating income, making the cloud division the financial engine funding much of Amazon's expansion. The company's AI business has now passed an annualized revenue rate of $25 billion. Amazon says its custom chip business has also exceeded a $25 billion annualized rate. Those numbers suggest that the investment is producing real revenue, but they also reveal why the spending cannot stop. Cloud computing works differently from an ordinary product business. A retailer can manufacture inventory and place it in a warehouse until someone buys it. Computing capacity cannot be expanded instantly when demand suddenly appears. A new AI data center may require years of planning. The company must acquire land, secure permits, connect to an electrical grid, construct buildings, install cooling systems, purchase processors and memory, and connect thousands of machines through high-speed networks. Every part must arrive at approximately the right time. A building without electricity is useless. A server without advanced memory cannot run demanding AI models efficiently. A collection of powerful processors without fast networking cannot behave like one large computer. Amazon's $220 billion plan is therefore not simply a purchase of more AI chips. It is an attempt to build an entire industrial system around artificial intelligence. The increase from $200 billion to $220 billion was partly driven by higher memory prices. This detail may appear technical, but it reveals one of the most important changes in the AI economy. The central processor was once treated as the main component inside a computer. In modern AI systems, memory has become nearly as important. Large models contain billions or even trillions of parameters. These parameters must be stored and moved repeatedly while the model performs calculations. The processor may be capable of enormous mathematical throughput, but it cannot work efficiently if data does not arrive quickly enough. Imagine building a factory filled with thousands of extremely fast workers. Their speed creates no advantage if the parts they need arrive through one narrow doorway. High-bandwidth memory widens that doorway. It places extremely fast memory close to the AI processor, allowing large quantities of data to move continuously. But producing this memory is complex, and demand from Amazon, Microsoft, Google, Meta, Nvidia, and other companies has increased rapidly. The result is higher prices and pressure across the semiconductor supply chain. Amazon is effectively paying billions more not only to increase capacity, but also to prevent expensive processors from sitting idle while waiting for data. This explains why AI infrastructure cannot be measured only by counting GPUs. The real unit of competition is the complete system: processors, memory, networking, electricity, software, cooling, and physical space. Amazon is also trying to reduce its dependence on external chip suppliers. Oz offers custom processors including Trainium for AI training and Inferentia for running trained models. The purpose is not necessarily to eliminate Nvidia. Instead, Amazon wants more control over performance, availability, and cost. Nvidia GPUs remain highly flexible and are supported by a mature software ecosystem. They can train many types of models and are familiar to researchers and developers. Custom chips make a different trade-off. Amazon can design Trainium around the workloads running inside AWS. It can optimize the processor, server, networking, software, and data center layout as one coordinated platform. If that integration lowers the cost of producing each AI response, the savings become enormous when multiplied across billions of requests. This is especially important as the AI market moves from training toward inference. Training creates a model and may require a giant cluster for weeks or months. Inference happens every time a customer uses that model. Every generated sentence, translated document, product recommendation, coding suggestion, image, or AI agent action consumes inference capacity. A successful AI service may need to answer millions of requests every hour. The companies controlling the cheapest reliable inference infrastructure could gain an advantage even if they do not create the most advanced model. Amazon's strategy is therefore broader than selling access to computing machines. It wants to control the layers underneath the AI economy. At the bottom are Amazon-designed chips and data centers. Above them is Oz, which provides storage, databases, networking, and security. Then comes Bedrock, Amazon's platform for accessing and building applications with models from companies including Anthropic and other AI developers. At the top are business applications, coding tools, shopping systems, advertising platforms, logistics software, and AI agents. Each layer creates demand for the layer below it. More AI applications require more inference. More inference requires more chips. More chips require more memory, electricity, cooling, and data centers. This is why a $220 billion spending plan can still feel insufficient. Amazon says demand is already reaching into 2028. That does not mean every server has been sold 3 years in advance. Large customers frequently sign long-term commitments that reserve portions of future capacity. These agreements help Amazon justify enormous construction projects. They also reduce risk because the company knows customers are waiting before the infrastructure is completed. But long commitments can create a different danger. The AI industry is changing rapidly. Models are becoming more efficient. New chips may perform more work with less power. Smaller models may handle tasks once reserved for enormous systems. Customers could shift between cloud providers or begin operating more infrastructure themselves. A data center may remain useful for decades, while the computing equipment inside it can become outdated within a few years. Amazon must therefore build for demand that exists now while predicting what customers will need in 2028 and beyond. Build too slowly and customers move to Microsoft or Google because Oz cannot provide enough capacity. Build too quickly, and Amazon could own expensive facilities filled with equipment that earns less money than expected. This is the central financial risk of the AI infrastructure race. Amazon reported extraordinary quarterly profit, but a large portion came from an increase in the value of its investment in Anthropic rather than ordinary operating cash. At the same time, heavy infrastructure spending has placed pressure on free cash flow. Capital spending is paid today. Revenue may arrive gradually over many years. Investors must decide whether Amazon is building the foundation of a future trillion-dollar cloud business or participating in an investment cycle that has become too aggressive. The latest market reaction suggests investors currently believe the demand is real. Amazon's shares rose sharply after the results, partly because Oz growth accelerated enough to make the increased spending appear more defensible. This was different from earlier moments when investors punished technology companies for announcing larger AI budgets without equally strong evidence of revenue growth. Amazon is now showing both sides of the equation. The spending is enormous, but the cloud business is expanding quickly. Capacity is expensive, but customers are reserving it years in advance. The harder question is whether this demand will remain profitable. An AI company may consume huge amounts of cloud computing while losing money on every user. Startups can sign large cloud commitments using funds raised from investors. Model developers may receive investments from cloud providers and then use part of that money to purchase computing services from those same companies. The transactions are real, but the industry can become circular. A cloud company invests in an AI laboratory. The laboratory spends the capital on the cloud company's infrastructure. The cloud company records rising demand and uses it to justify building more infrastructure. This structure is sustainable only if businesses and consumers eventually pay enough for AI products to support the entire chain. Amazon has an advantage because AWS serves far more than experimental AI startups. Banks, governments, retailers, manufacturers, software companies, streaming platforms, and healthcare organizations already depend on its cloud. AI can be added to existing workloads instead of creating every customer relationship from zero. Amazon also operates businesses that can use the infrastructure internally. AI can improve warehouse robotics, delivery routing, product recommendations, advertising, customer service, pharmacy operations, and the tools used by Amazon's own software engineers. This makes the investment both an external cloud business and an internal productivity strategy. Still, the expansion faces physical limits that software cannot remove. Electricity is one of the largest. A major AI campus can consume power comparable to a city. Data centers must compete with factories, homes, and other industries for grid connections. New power plants and transmission lines take years to approve and construct. Amazon can purchase processors quickly compared with the time required to expand an electrical grid. Water and cooling create additional constraints. Powerful chips generate enormous heat. Facilities must remove that heat continuously while operating reliably in different climates. Land availability, transformers, construction workers, fiber connections, and backup generators can also delay projects. The cloud may appear invisible to users, but it depends on some of the largest physical machines humans have ever built. This changes the meaning of competition in the technology industry. For years, companies could gain market share by releasing better software. Software can be copied and distributed globally at extremely low cost. AI infrastructure behaves more like energy, transportation, or heavy manufacturing. It requires factories, supply chains, long-term contracts, scarce materials, and billions of dollars committed before the customer receives the final service. Amazon's strongest advantage may not be one model or one chip. It may be its ability to finance and coordinate this entire system at a scale few companies can match. But scale also magnifies mistakes. A small startup can change strategy quickly. Amazon cannot easily cancel a network of data centers after ordering equipment and securing power contracts across multiple regions. The company is betting that artificial intelligence will become a basic layer of the global economy, similar to cloud computing itself. If that prediction is correct, $220 billion may eventually look like the cost of securing a dominant position before demand fully arrived. If AI revenue grows more slowly, prices fall too quickly, or efficiency reduces infrastructure needs, the same spending could become one of the largest examples of overbuilding in corporate history. For now, Amazon's results provide the strongest evidence that the boom is not based only on promises. Oz is growing, AI revenue is rising, future capacity is being reserved. Yet the company's most surprising message is that even $220 billion cannot remove the shortage. The next phase of the AI race will not be decided only by which company creates the smartest model. It will be decided by which company can deliver enough memory, electricity, networking, and computing capacity to keep those models running for billions of users. Amazon is betting that the future of intelligence will still depend on whoever owns the largest machine underneath it.